Hey everyone, so in this video, Daniel is going to explain how you can use Azure OpenAI services in Azure. And this is a complete hands-on lab on how you can create a model, choose a model, what are the things you can do within a model to extract the results out of it. I learned heaps listening to him. I hope you are going to learn a lot as well. Thanks for Daniel for spending a lot of time with us, teaching us how to use Azure OpenAI services in Azure and how to configure it, and talking about the different use cases on where it might apply as well. Thank you so much, and I hope you enjoy the video.
Before we get started on doing a demo, the first thing we need to understand with the Azure OpenAI service is that it's a limited access service. This is an incredibly powerful technology, but it can easily be misused. And so Microsoft puts a registration process that requires you to first request access to the Azure OpenAI service before you can deploy the Azure OpenAI service resource to your subscription. So the first thing you need to do is go to this page, and we can probably share a link there, but it is aka.ms/oai/access. That will take you to this registration form. You will then need to fill that registration form in with your company details, along with the subscription IDs of the subscriptions that you want to use what Azure OpenAI service to be available in. Now, it's really important you can provide 3 subscriptions, but if you had many subscriptions, you're going to need to submit this form multiple times. But I would recommend getting it done once and seeing how it goes. It will usually be responded to very quickly. This is not shouldn't be an arduous task, but it is just to ensure that you are going to be using the system, this powerful technology in a safe way. So once you've done that, after a day or two, you should get a response back, and you can then start using the Azure OpenAI service. So I'm going to go into my Azure portal here, and hopefully you're familiar with the the Azure portal. This is the current portal with the fantastic Azure AI Copilot. We're not going to cover that today, but just pointing it out. So the first thing we need to do is create what we call an Azure OpenAI service. Now we can create multiple services within a subscription, and the service needs to be created within one of the regions that Azure OpenAI is available in. So what I'm going to do is I'm going to click the create a resource, and I'll click the Azure OpenAI service, which will list all the Azure OpenAI services I've already got deployed. But another way to do this would be just searching for Azure OpenAI, and it will bring that up. And of course, it brings me here, and then I can click create. Now you can see I've already got some services pre-created, but I'm going to create a new one. And I've got to select a resource group where I want to deploy this resource or create this resource, and I'm going to create it in this AOAI test resource group. I'm going to choose one of the regions where Azure OpenAI is supported. It's not supported in every region, be aware, but a large number of regions. But I'm going to deploy to Sweden Central because I know that's got some fantastic models available in it. Another thing to remember is not every model not every OpenAI model is available in every region. There is a page in the Azure OpenAI service documentation which shows the model availability for all the models. So I will share a link to that in a moment. So we'll go and name our deployment or Azure OpenAI service, and I'll call it AOAI test SWE for Sweden. And I only have one pricing tier, which is standard S0. Here is the information about the content protections that are wrapped around the model. It's highly recommended reading this, and then click next. And we can select, as I mentioned, we're allowed to put the model inside a private network, but in this case, we're going to make it publicly available, and click next. And then we can set up any tags, which we don't need to do, and click next again, and we're going to click the create once it confirms that everything I've entered is correct and valid and good to go. So I'm going to click create, and it's going to submit my deployment. Now this is deploying the service. I haven't yet created or selected any models that will be available inside my service. So I will wait for this to deploy, and as you can see, it'll jump across and change my screen in a moment.
So while that is happening, Daniel, can you explain
Yep.
the pricing tier? I know that you said you can only select S0. What are the other pricing models and what are the differences on a high level?
So yes, so from a high level, there is only standard S0.
Yeah.
Uh, Perhaps at some point there'll be some other pricing tier. There is something called, as we mentioned, provisioned throughput, which allows you to basically buy provisioned or reserved capacity on the model and make it on a specific model in a specific region and make that available. Now that's something that is a pricing tier, but it's not something you need to select when you deploy the service.
Yeah.
So at this point, there is only one pricing tier and it is standard S0. Perhaps there'll be another one in time, but at the moment, S0 is all we've got.
Okay. Got it.
So now we have deployed our resource, we've deployed our service, and we can go to the resource, which will take us to the Azure OpenAI service page, overview page, where we can see a number of different settings for the service, where it's deployed, Suite and Central, that it's an OpenAI service, standard pricing tier, as you mentioned. But what's really important, these are the click to view endpoints. This is the API endpoint, the URL that our model is actually available on. So we can actually use this URL to connect to the Azure OpenAI service and send. Remember those showing those API requests before? That's the
Yeah.
URL we would use to send to that send request to the model, to any models that we've got. Um, but heading back to the overview, we can also see a number of other little bits and pieces. We can see the keys. So remember, we need an API key to communicate with the model. If we're using Entra ID, this is slightly different. But for the purposes of this demonstration, we're just going to use the keys. We can copy those, store them securely in a key vault, because if someone was to get access to those keys, they can call our model and incur costs. And we ideally don't want to do that. Only our application should do that. There is a number of other little bits and pieces, for example, networking, which is what I mentioned before, enabling private network endpoints. So putting that service, that API endpoint I just showed, could be put inside a virtual network so that traffic from your application travels only via the private network to the Azure OpenAI service. We can do cost analysis. We can also have a look at monitoring. So we can set up diagnostic settings so that every request that is sent to and from the model is recorded in an Azure Monitor service, or even sent to an event hub. Now, this doesn't store the prompts themselves. For example, the actual text we send to the model and the text we get back, it doesn't store those. It does store the size, the number of tokens in those requests, but it does not store the actual information, because that could be a security risk. If we wanted to do that, we should do that within our application tier itself. So we won't set that up, but it's as simple as clicking the Add Diagnostic setting, specifying a log analytics workspace, and giving it a name and saying we want our request response logs, audit logs, and trace logs, or whatever we want. And we can send it to all sorts of different locations, but we won't need to do that here. But what we really want to do is start developing, start building some prompts. So I'm going to go back to the overview here, and we will notice down the bottom here, it's got our next steps. So we've got a number of different options. The one we want to go to is the Azure OpenAI Studio. Now it looks very similar. We've got Azure AI Studio. Azure OpenAI Studio is really a subset of Azure AI Studio that just focuses on OpenAI. So we're going to click that, and it's going to take us to oai.azure.com. So we didn't have to click that button. We could just type oai.azure.com. If we're not logged in, it's going to ask us to log in, and it's going to take us to something called the Azure OpenAI Service Playground, or Azure OpenAI Playground. It's just logging us in, and then we have to do some next steps, because we've got our service deployed. It's deployed into Sweden. Now we need to deploy some models. So as I mentioned, there's lots of different models available from OpenAI service. We can go down here. So this is what the Azure OpenAI service looks like when we land. It's told us we've got no deployments detected. These are the models. So we don't have any models deployed. So that's what we got to do first. But let's quickly, before we do a deployment, let's look at the models that are available to us. So if we click down here in models, we will see a list of models. There's quite a few. So as I mentioned, the DALI 3, that's image to text. We'll skip over DaVinci, that's an older model, GPT-3.5 Turbo. And as I mentioned before, they've got 3 different versions of GPT-3.5 Turbo. Each of them are a different model version. Now, this number here represents actually the date the model was released or trained. In this case, it is 0125. That's 25th of January 2025. They've actually changed the versioning standard now and make the version number a little bit clearer, but that's January 2025. And that's November, 6th of November 2023. So this model here is older than the 0125 model. It's a little bit unclear, but
Mm.
it's important to understand that. And we can
But
see
we can
that.
keep a look at the date to actually figure
Yes,
out. Yeah.
exactly. So that created date makes that clear for us. We can also see things like GPT-4 Turbo. There are some specific ones around Instruct. We won't go into too much detail there. They are a special model that is trained to follow instructions as opposed to be a chat type model. We mentioned the vision preview. That is a multimodal vision model. We have a number of other preview models, and GPT-4o, which is probably the most capable of all the models. In fact, it is the most capable of all the models. We only have one version of that, and that was trained 2024-05-13. There is also embedding models, which we didn't talk about, and then we will talk about that in the next section, which is talking about RAG and vector and embeddings. And finally, the TTS, TTS-HD, and Whisper models, and that's text-to-speech, so that's taking some text and generating some voice, and the HD version, and Whisper, which is taking a recording of a conversation or someone speaking and turning that into text. So the first thing we're going to do is deploy one of these models. Now, as I mentioned, GPT-4o is the best model right now. It is very, very capable. It is multimodal. It's very fast. So I'm going to tick the box, and I'm going to click deploy. And it's going to ask me a few questions. So it's going to ask me a deployment name. Now, I'm going to call it GPT-4o, but you might deploy multiple copies of the same model. Perhaps you've got 2 teams or two features. You're building an HR chatbot and you're building a chatbot for finance. You might have a deployment of GPT-4o for finance and one for HR and keep them separate. And this could be for a billing perspective. It could be for a number of other different reasons. But in my case, I'm going to have one copy. Just going to call it GPT-4o. Again, I've already selected the model. GPT-4, I could select others. I get to choose. Do I want to specifically specify a version, or do I want to auto update the version so that whenever a new version is available, the model is updated? Now, that's a decision you'll need to
Mm.
make. It can be important to understand how models are updated, because you'll need to, because as new models are released, eventually older models are deprecated. And there is a document that Microsoft provides that shows how models are deprecated and how you need to plan for it and what you need to consider. Again, we can share that. And the next choice we have to make is a deployment type. Now, there are 3 deployment types. Deployment standard is where we deploy the model to the region that we've chosen, that the service is deployed to, so in this case, Sweden. And all of our requests are going to go to Sweden. They're going to go to this model. And if we use the model endpoint that we showed before on that model endpoint, it's going to go to Sweden. However, we have this global standard option. And what this does is it makes the model available across all regions that the model actually is available. And when we send a request to the model endpoint for this particular deployment, it will route the request to the region that has the current lowest loading and latency for us. So this has a great advantage of saying, well, if a particular region, the models are very heavily loaded and they're responding a little bit slower than we'd like, we can have Azure OpenAI Service automatically route our request to that lowestly loaded region. Now that may have a consequence that it could violate your governance process. Perhaps you need to keep your data within region, or you need your application tier to be as close to the model as possible. So you might not choose to use global standard, but just something to be aware. It is available. I'm not going to use it. I'm going to use standard. But just calling out, the last option is provisioned managed. And now that is available to you if you've pre-purchased or reserved capacity for one of these models. So you've said, I know I need a large amount of requests to GPT-4o for this particular region. I need it 24/7. I need to have a very consistently low latency. You might choose to pre-provision or purchase that provision managed capacity, and that will then be selectable for you. I don't have that. As you can see, if I choose it, it's going to tell me, no,
Mm.
you don't have that. Not available to you. So I'm going to go
Right.
with
So
standard.
that means you have to pre-purchase and make it available in your tenant so that you can select it.
Exactly, exactly. And there is a process to doing that, and it's really the most it's available to everyone, but usually the larger organizations with large volumes and very low latency requirements can choose. If you don't need if you're trying this out, if you're experimenting and learning, if you're building a system that's not accessed by millions or hundreds of thousands of users, or we don't need consistently low latency on every request, we can accept a little bit of variation, we can just use standard.
Yeah, because I can see that it allows you to 150K tokens per minute. That's a substantial amount of tokens, I guess, I assuming.
It is, but it's quite a bit.
Mm.
But in reality, if we were to say have 1,000 users interacting, typing a message to this chatbot, of say 1,000 tokens on every request, and we've got 1,000 users, we are easily getting up to a million tokens per minute.
Mm.
So we do need to model this. We do need to consider, what do we need now. That quota, that is the default quota. We can actually request more.
Mm.
So if we were to say, we actually need more than that, we can make a request and that will potentially be increased. There are other ways of also of looking at how we might move around that quota. We might choose multiple models. We might actually deploy to multiple regions and balance our. We might say we've got Sweden Central, and we've got one of the other regions in Europe that this model is available, and we might load balance across those regions to increase our quota, because we have 150,000 tokens for GPT-4o in Sweden.
Mm.
And I will add, just as a caveat, it's actually per subscription. So if we had 3 Azure subscriptions uh, with Sweden Central, an Azure OpenAI service deployed in each subscription to Sweden Central, and we deployed GPT-4 in 4.0 and each one of those subscriptions in Sweden Central, we would actually be able to get 450,000 tokens available to us. So that's 150,000 times 3 times each subscription in each region. So there are ways of, but we would need to manage that and load balance, and our application
Mm.
would need to determine, where do I send my requests. So there's a lot to be managed or thought about as when you're thinking about and planning for your quota. But 150,000 is a lot, but when you start to get hundreds of thousands or millions of users, or requests going through your system, that is something you need to plan for. But I'm going to drag this all the way up and use all 150,000 tokens. You might have noticed if I actually change this to global standard, I actually get 450,000 tokens. So it's just a little bit of a, and that's documented on the quota page. This is because we're actually spreading our load across multiple regions, so we can do exactly what I just said, which is, deploying multiple region Azure OpenAI service to multiple regions to spread our load out across this. Except global standard is doing that load balancing for us automatically. But I'm going to go back to standard, drag this to 150. I mentioned content filtering. There is always a content filter enabled with these monitors. The content filter looks at the traffic going, looks at the requests going in and the content coming out and verifies them against a number of harms. And we'll talk about those harms in a moment. But that content filter has to either be set to default, or a content filter we could choose to set later. We could create a custom one that was maybe more sensitive to violence or something else like that. So we'll set that, and we'll leave the dynamic quota enabled, and we'll just click create. Now, what that has now done is it's deployed our model. So there's our model there. It's now available. We can see our rate limit. We could edit that deployment, change the version and so on, but there's a whole lot of things we can do. That's all we really need to do to get set up. So we are now ready to start writing some prompts.
And
So that
there is no additional cost on selecting different models, right? The costing will only depends on the prompt or the calls we are doing with the tokens and things like that.
100%. So right now, there is no cost to anything we've done. We are
Okay.
not going to incur a single cent until we make those API requests to the model.
Okay.
Right, so we could have as many of these models deployed as we like, and no charge. But what we're going to do is we're going to go and look at the playground. Now there are a number of them. There's chat, DALL-E, chat completions, DALL-E, and assistance. Chat is where we're going to spend most of our time. Now, even if we're not building a chat interface, we're not actually, perhaps we're building a system that automatically looks at user posts against our product. You're building a retail store, and we want to look at what users are saying and get some extract meaning out of that. You wouldn't do that as a chat, but it still uses what we call the chat interface to the model. So chat is where we're going to spend most of our time. So we click chat, and this opens up the chat playground. And this, I will minimize that. This is where we get to set up what we are going to do to interact with the model. So the first thing we're going to do is we're going to select our deployment. Remember, I said we could have multiple models. I've only got the model I deployed, that's GPT-4o, and we hover over it, we can see all the details. We can also specify the number of past messages that should be included in our request. Now, we actually are going to turn that all the way down, because we
What
actually
is the
not building a
past
chat.
messages mean, Daniel?
So if we were building a chat UI or a
Yeah.
chatbot, every time we interact with the model or send a request to the model, we're going to include the
Mm.
previous messages that we had in the chat.
Yeah.
So this is how we give the model context. Because one important thing to remember about these large language models is they have no memory. Every request we send to them, there is no knowledge of any previous requests. It's like they've never seen or heard from us before. We've never interacted with
Mm.
them before. They are stateless models. So if we want to include the past chat history as context when we send the message to the model, we actually have to include that in the prompt, and we'll show you what the prompts are going to look like. But what
Mm.
I'm going to do is I've got an example here that I'm going to pull out. I'm going to build a fraud detection model, or fraud detection system. And my mouse is, hang on a sec. Give me a sec. I'm just losing my mouse for some reason. Okay, there we go. So I'm going to build a fraud detection model. I'm going to I'm going to build a fraud detection system using a large language model. So the first thing I need to do is set the system message. So the system message is included in every prompt to a large language model. It provides the guidance and the guidelines for what the system should and should not do. It shouldn't be dynamic. It should be set by you and fixed. Now, if you've used something like ChatGPT or Microsoft Copilot, you won't be used to setting this, because in those cases, for ChatGPT, OpenAI sets the system message for you. And for the case of Microsoft Copilot, Microsoft sets the system message for you. You don't get to change it. And this provides all the guardrails for your system. And in this case, what I'm going to do is I'm going to set my system message to this. You are a financial AI assistant that helps identify bank transactions that might be fraudulent. Okay. I'll get rid of this X. We don't want any templates. We're going to apply changes, and it's going to say, are we sure you want to update the system message? It's going to change the behavior of the system and reset the system. So we're going to do that. We're going to get rid of, we're not going to use any examples. Examples are a way for us to include in the prompt guidance by way of example. And these are what we call one-shot or few-shot examples for the model and how to behave and how to answer our question. We don't need that in this case. What we're going to do is I'm going to grab this and I'm going to put that in here. So what I'm doing is I'm saying to the model, this is the use of this, I'm providing context to the model and instructions on determine if the following transactions are likely to be fraudulent. You must provide the following information for each transaction. The date format is in this date format. I want you to give me the answer like with five tabular columns, so transaction date, description, amount, percentage, likelihood the transaction is fraudulent based on the previous transaction. And I want the model to explain the reason why the transaction is likely to be fraudulent. It's actually likely to be fraudulent. I've asked it to give me it in JSON, which, of course, if you're writing this as part of an application, you need the output from the model to be in a machine readable format. I could give it, I could ask you to ask the model to give us to us in, say, a CSV or text or whatever you like, but JSON's great for machine readable. Now I've included some semi-structured data, the transactions. These are the transactions I want to evaluate. Again, I've set it up here. You must provide the following for each transaction below. And here's the bank statement. So this is just the recent bank statement, and we're wanting to evaluate each of these transactions against the bank statement. We're wanting the model to do that. So let's run this. So that is actually going to call the API that we've for our deployment along and pass the formatted prompt through to the model. And this is what it's come back with. So the first transaction, which was rent, it said the fraud chance, 0, not likely to be fraudulent. This transaction, but the reason why it's not fraudulent, the transaction matches the regular rent payments in both amount and description. Cool. We didn't instruct the model on how to do this. We didn't tell it what it should do. We just gave it some instructions, and it's figured out the rest. Now the second one, 90% fraud, 90% chance of fraud. Now, the reason for that is rent payment made twice in consecutive days is unusual and could indicate a duplicate or fraudulent charge. And that is correct. It is, you've paid rent twice in a day, and it's probably a problem. The third reason, 95% fraud chance. This is because rent is misspelled. Misspelled description for a typically recurring transaction suggests potential fraud or error. And finally, there's an 80% fraud chance of the fourth transaction, which was groceries of 490. Now, the reason for that, if we look at our regular groceries, they're around 100, 150. Suddenly, we've jumped up. Now, this could be it's significantly higher. Maybe we're just spending more that month. Maybe it's we've got a family visiting and we need to buy more food. So it's not 100%, it's 80%. And then we could use this information and ask more follow-up questions. So we could say, how might we detect if the gross, how might we also, the groceries transaction is fraudulent. Now, what's actually happening is we are providing the question, which is providing the prompt, which is generating the prompt with the previous conversation we've had. So that is including my previous instruction along with the previous output, and then appending this. So this is what this past message is included is doing.
Mm.
So again, it's giving us some instructions based on that. Now, our application might do this. Our application might say, we've identified a potentially fraudulent transaction. Here's some instructions on what you should do to follow up on this or go next. And as you can see, it's repeated the transactions. Here's a revised with the additional factors, which is great, fantastic. What actually happened in the background? So when we're in the Azure OpenAI playground, we get the ability to have a look at the code. So if we click the view code, what we can see is exactly what was sent to the model. And this is using Python, but we can actually change the code to C#, Java, Go, JavaScript, whatever you like. Most common languages are there. But if we look at Python, if we show Python, we can see we've potentially including images, but we're not including any images there. We've got the payload, which remember, there's the system prompt. Remember, system prompt says you are a financial AI assistant. That's what I put there. The text is what the model responded with. So this is the assistant's response. So there's what I just sent. And then if we chose to, we could go back and repeat the process with another prompt. So we could follow this up with a, let's increase that, and we'll say, what else could I do myself safe from fraud? And of course, what we are then able to do is view the code again, and it will give us an updated view of the prompt that the assistant. So we've got our system prompt. We've then got the question we asked, and we've got the previous responses. So this is the previous rounds of conversation, along with our next question and then the response to that question. So this is how we would format a conversation or send requests and responses to a conversation. Now, we might be tempted to write all this code ourselves. There's actually a number of SDKs that will manage and do all this for us. There is, of course, Semantic Kernel, which is a Microsoft open source SDK that will take care of a lot of this work for you. There is the very popular LangChain, which is a Python-based framework. There is a number of others as well, and they will all do all this work for you and simplify the process. But if you just want to see how it works, this is a good way of doing it. Now, a couple of other features in the playground that we'll quickly talk about is these buttons here, which are the ability for us to enable text-to-speech and speech-to-text, just to see how this works. So if we go and click Chat Capabilities, what we can do is we can actually select a speech resource. I don't have one deployed, but this will use Azure Speech, and it will automatically convert allow me to speak to the model, actually have a conversation, and it will generate audio back for me. But that's something we don't need to demonstrate for a large language model. It's just nice to know that we can easily do that within the Azure OpenAI Service playground. Now, there's a few other little important features that we want to mention here. If we go to parameters, there is a number of ways of controlling the model behavior, and these are really important. They are passed as parameters. If we look at the code, we will see these passed in if we customize them. I haven't yet, so there we go. We've got the temperature, we've got TOC-P, max tokens, and we'll talk about those. So every large language model has a limit on the number of tokens that can be sent to and from the model, the number of tokens in a single request. As we mentioned, a token is roughly 0.75 words. Roughly, it's usually three or four letters or characters. We are able to limit the length of the response the model will return to us. We're able to limit the response, the number of tokens that the model responds with. If we want a single sentence, we might limit the response to 100 tokens. If we want a very large, page or 2 pages full of analysis, we might limit it. We might say we want 2,000 tokens. But that number of tokens that we want in the response, the maximum number or size of the response, we will need to take into consideration that every request and response to a model consumes some number of tokens, and every model has a limit to the number of tokens in a request response.
Mhm.
For example, GPT-4o, in a single request response, we can send a maximum of 128,000 tokens. Right, that's a lot. That's a good number of books. But for a model like GPT-3.5 Turbo, the first model, that had a limit of 4,000 tokens. So as models capability increases, generally we are seeing a larger, what we call context window. This number of tokens is called the context window. And we need to factor in the size of our input. We might have, we might be inputting all our policy documentation on how we detect fraud. And that could be 50,000 tokens. And we might include that in every prompt. That would be very expensive, to be honest, if we're doing millions of these prompts. So we'll talk about how we can work around that. And we need to factor in how much output do we want. So we can guide the model by setting the max response, but we can also say in the request, I want you to limit your response to 1 sentence or whatever. So we can provide guidance to the model on how long we want. The second or third important thing is we can actually set a stop sequence. So this is a set of characters that we want to look for in the model stream that will cause the model to say, I'm done. So for example, we might say a full stop is a stop sequence. Anytime we encounter a full stop, that's it, we're finished. So that would be another way of saying, only give me 1 sentence. We often use this for if we're generating JSON output, for example. If we've asked the model to create some JSON or some structured data, we might say the stop sequence is a curly brace, because that's how we actually terminate a JSON structure. So that's another way of stopping the output from the model. These two settings here, temperature and TOC-P, are very much related. These models, large language models, are non-deterministic, meaning they will typically, if you send the same response in multiple times, you're going to get different responses back from the model. The amount of non-determinism, or the amount of variance within the or creativity of the model when it gives us our output, is set by the temperature. So the temperature setting a high temperature for the model will cause the model to be very creative, but it might hallucinate. It's more likely to generate, slightly different or off topic responses. Whereas if we want to be very constrained and very rigid and not that creative, we might drop the temperature to 0. So you will decide, based on what you're building, how creative you need the model to be. Get rid of that. The TOC-P allows us to specify how what likelihood is that a token will be selected from the neural net. Increasing the top P will increase the variation in the tokens that are selected. Typically, we will only increase the temperature and not the top P, or we'll increase the top P and not the temperature. We don't typically increase them both together. But what we always recommend is experimenting with these settings to evaluate the responses you get and configure your system to set those settings. That does bring us down to how do you evaluate this at scale, and that is a discussion for Azure AI Studio, because that is what Azure AI Studio allows us to do, is to move those settings around, evaluate and compare the responses at scale. So that is the chat playground. We're going to show one quick other feature, which in itself we're going to cover a little bit more detail in the next session, but that is add your data. So a lot of the times we ask the question, I have a bunch of private HR documents, or I have a bunch of private or specific documents that I want the model to look at when it gives me my answers. Perhaps they're HR documents, or perhaps they're just current news articles, or perhaps they are white papers for generative AI. So what I am able to do is click the add your data and add a data source. I can then select a data source, and this is the source of where our documents or our source data is. I can actually select upload files. I can select blob storage, or right now that's not in preview is the Azure AI search. This is an existing index, and again we need to cover that in retrieval augmented generation. But just as a demonstration, actually I haven't got this set up, so just as a demonstration, we select Azure AI search. And I have set it up. Okay, cool. Okay, adding your data allows you to add a data source, either an index or a set of documents from an external data source, and make that available as part of Azure OpenAI service when you are building your prompts. Now, it's important to understand that this is not training or fine-tuning the model. This is just injecting the relevant documents into the prompt that the Azure OpenAI service, that the chat playground actually writes on your behalf. So what is actually happening is it's changing the code that is written in the playground based on the documents it finds as relevant from the data source you specify. So if I click add your data source, I'm going to demonstrate building a product solution that looks at a product database, a database of products, and provides product recommendations based on inputs from the user. I have already configured an Azure AI search service. This is a vector. This is a search service that allows us to search over an index of documents or data. This is already pre-configured. We will talk about a little bit about that in a later session. I have got a pre-configured index called products. That is essentially a list of all the products. In that service, I am going to, okay, you know what I didn't do? I'm going to stop there. Give me a second. I need an embedding model to do this, which is this one here. Actually, I think I did it with Ada, so I'll use that.
We will go through this when we talk about RAG, right?
Yeah, because this is sort of going to be a this is giving you a really, because when we go through RAG and vectors and things like that, we need to, there's a lot more sort of visualization. I've got an entire session already set up for this. So you need to understand the basics before we go, oh, here's an embedding model, because you go, what's an embedding model? So what we're going to do is, now that's deployed. Let me just check everything before I do it, before I kick it off again. Products, yeah, there we go, embedding. Okay, cool, that's done. Okay, so now, all right. So we're going to now create a product AI or product chat that will allow us to ask questions and interact with a large language model that will have access to our product catalog, so it can answer relevant questions about our products, suggest products for customers, and be more helpful. And it's going to do this by we're going to do this by adding a data source to the chat playground that the model can then use. Now remember, the model is not interacting with the data source directly. It's actually the playground is creating some code that is able to look at the data source and then putting that into a prompt behind the scenes and sending that prompt with the relevant data to the model. So I'm going to click add data source. I'm going to select Azure AI Search. Azure AI Search is a search, an index search solution inside Azure. It is somewhat based on Elasticsearch, but it has vector search capabilities, which are all things we need, and we'll cover in a later session. But these are all things we need to allow our chat playground or our solution to look up the relevant data from our product index. So inside our Azure Search Service, we have a product index. We're going to use vector searching to ensure we find the most relevant products. We'll talk about that in a later session. I'm going to use an special large language model called an embedding model to generate the vectors. Again, we'll talk about this later. That just allows us to refine ensure we are selecting the relevant information. We're selecting a search type, which is vector, which is definitely the most the best way to search this index. And we're just going to use an API key. And what's happening in the background is the chat playground is going and checking the index I've selected and making sure everything is all working correctly. And I can then save and close. Now, it has got our data source available there. And now I might ask and say, I'm feeling correction. I have to now, you're no longer a financial assistant. Instead, you are a helpful, actually pause there. I'm going to copy the text because it's actually a long prompt I need for this. Hang on a sec. There we go. Okay, I've got it.
Awesome.
All right. All right. So continuing. So now that we've added our data, we next need to set the system prompt. So as I mentioned, the system prompt governs or controls or guides the LLM on how it should behave, what it should do, what it shouldn't do. I have got a very special system prompt that I've created, and we'll run through it very quickly. That will show us you are an AI assistant for Hammerbarn, a retail store that provides goods and home improvement. You help shoppers select goods and ensure they are provided with the information to use them correctly. You will explain your thinking to customers by showing how any recommended products will be used to address their need. You're always polite and helpful. You include a numbered list of items whenever applicable. You make witty home renovation puns, etc. This is all prompt engineering. We are providing guidance and guardrails. We're constraining the model to what it can and can't do. We are also including a section on safety and guardrails. Now, you don't have to use this formatting. The models are typically use Markdown. They understand Markdown very well. So that # is a Markdown tag that would indicate this is a heading. So the model will pay a little bit of attention to that, or more attention. And we're guiding what it can talk about, so what you can discuss, what you can't discuss. You won't make any recommendations that could be dangerous or harmful. You will not make any recommendations for any other store. For example, don't recommend another home store. So we've put some constraints into the system prompt. Now this means that the user can't override these constraints. The model is trained, actually fine-tuned to very much pay attention to and prioritize the system message. So I'm going to apply those changes. So now we've set up our AI. We've given it some data. We've set up the system prompt. We could include some more previous messages. Perhaps we want to have a conversation. We are going to allow the model to send back 2001 tokens. We're going to make it a little bit creative. I want it to be creative about what it says. We'll drop the top P down to 50. Right, so we've set everything up. We could see if we wanted to interact with the system, we'd actually see what is going to happen, but we won't go into any detail there. But as you can see, we're actually specifying an index. But let's ask the model. It's very cold. Actually, it's very cold at the moment. So let's do that. My AC is broken. I need a portable one stat. So what's actually going to happen here is, rather than our prompt just being sent to the model, we're actually first using something called Retrieval augmented generation, which is going to our index, looking up relevant products using that vector index, and then bringing those products back and injecting them into the prompt and saying to the model, hey, the user is asking for these things. My AC is broken. Here's some relevant knowledge. I want you to answer the question based on the relevant knowledge. So as you can see, what's happened is the model has come back and said, hey, I've got you covered. You've got some great options here. And it's even given references. So the model is still generating. This is my browser that's taking its time. You could probably cut that. There we go. And as you can see, here are the 5 products. This is the products from the index that were used and passed through to the model. So if we click on view code, we can see that, again, we're selecting the model deployment. That's our endpoint. Remember, we're in Sweden. GPT-4o was the model deployment name. Oops. We specify the search key. That is the key that Azure AI Search will go and access. That the chat playground will use, this code will use to access the Azure AI Search. We've provided the product, the index, which was products. And all of this code is written for us. Again, we're using Azure OpenAI service. We're creating a chat completion. Here's all the settings. And we are saying, hey, look, here's some data. Data sources such as Azure Search that you can use to go and query and get information from to use as part of your answer. So I could follow that up, and perhaps I'll ask, I've got a 2,000 square foot room. Now, of course, we use meters in New Zealand, but if I was to say square feet, or actually if I said in meters, the model would have a go at translating. It's not necessarily the best at doing those sorts of mathematical calculations, but we'll just say 2,000 square feet. Now, clearly, this is not this is not going to be good enough for a 2,000 square foot room. It's quite a big room, by the way. So what we're now doing is we are following up with the model. The previous interaction is being passed through in the prompt along with my follow-up question. So as you can see, it said no, it's not, because the heater is designed to heat 1,000 feet. Actually, which one was the ready one? Okay. So since your room is 2,000 square feet, you would need to use 2 of the Williams Pro, 2 of these. So yes, the model did exactly what it was supposed to do. It just did it at the bottom this time. So that's an interesting thing about these models. I've done this demo many times, and every time you get a slightly different answer. Now this answer is correct, but normally it puts it at the top and says, or previously it would say, hey, you would need to use 2 of these or 2 of those. But in this case, it's added it to the bottom, which is completely correct. And you would need to, that's why it's so important to have a methodology for evaluating any large language model solution, because you can't just do a text comparison, because the answer is still correct, but perhaps you actually wanted it to always put these sorts of suggestions at the top, and that is where examples would come in. But we're not going to use that demonstration here. So that is the chat playground in a nutshell. Sorry, actually, there's one last thing I'm going to add. Once we've got our system all set up. We've got this. This seems to be working. Everything looks great. We've got a working generative AI chat system. We can actually use this deploy to button to deploy this to a new web app in Azure OpenAI. In Azure. So that'll deploy an Azure app service with a web app inside it and put all this code inside it and run it all and set everything up.
Wow.
Or we can actually send that to Copilot Studio. So we might want to build this as a loco and use this chat as part of another Copilot, make that available inside Teams or make that available
Wow.
inside WhatsApp or any number of different solutions. We can actually take all of this and send it over there. That's still in preview. But the
And
most
then we
common way
can
is,
fine tune it here. And does it reflect the changes in the
well, we
app
remember
or the Copilot?
it's important we're not fine tuning, where everything we're doing is giving the model in context learning. So we're adding data or information into the prompt, and the prompt we send is all the context or all the knowledge the model has. It does not, we don't want to fine tuning, we can do, but we don't want to do that.
Yep.
So what
Yep.
this is doing is it is sending our system prompt, it's sending the information around our AI search, it's sending all of that and configuring that service with all of that information for us. If we were to change the product index, that information is automatically reflected in this new app service we've configured, because that's the data, the product information is in the search index, not in the web app itself. The web app is just talking to the search service. So if we were to change the product data, yes, it would be updated immediately. However, if we wanted to say change the system prompt, we would need to update an existing web app, and it will reconfigure it with any changes we've made to, say, the temperature or the system prompt or whatever. So we
Fantastic.
can create or update. It's an amazing way of getting started. There is of course, this is a great way to test, evaluate, and get something into production. But as I mentioned, we need a way to reliably and consistently and continuously evaluate these types of solutions. And usually deploying the solution to Azure OpenAI, deploying this to Azure is not just the end of the task. We need to monitor it. We need to update to new models. We need to tune and tweak. So we need to tweak and adjust the system message and evaluate that and make sure that all the safety processes are doing what we need them to do. So this is a great way to get started, but we typically want to do more, and that's where Azure AI Studio comes in. But we won't deploy that. That will take about 10 minutes to deploy. We can put identity around that. So we might want to require users to log in using Entra ID, but it's a really great way to build an internally facing chatbot. But there is another way we can do, and that we will cover in the next section, which is the chat over your data solution accelerator, which is another way to build all this stuff up without using the playground and do CI/CD on it and all the other things that you would do as part of a normal application lifecycle. But we'll finish up with one last piece, which is very important, which is what we call content filters. As I mentioned, content filters is a key part of Microsoft's approach to responsible AI. Microsoft is very committed to the responsible AI framework that we've built that you can find at https://akka.ms/RAI if you want to have a look what that looks like. But the responsible AI, the content filters service, which is available in Azure OpenAI service, is wrapped around every single model, and it allows you to configure the content filters to block and protect your system against various different attacks or threats or harms. By default, there is a default content filter which always has the four harms of I think it's violence, sexual harms, um, there's hate speech, and I should remember the fourth one. Actually, if we click the create content filter, we can see the four harms there. And this allows us to create a custom filter where we might want to be more protection, and it would allow us to add additional harms or additional checks on top of that. For example, we might want to protect against jailbreak attacks, where people try to bypass the system prompt. We can use prompt shield that protects against various other types of attacks that we might see against AI, against large language models. We can protect against regurgitation of content, protected content, e.g., song lyrics and copyrighted content. So we might say don't output anything that looks like it could be copyrighted or covered by another license. And again, similar here. So we get to set all that up. We get to set additional block lists around what things the model can and can't say, and we can turn on streaming mode. Actually, I'm wondering if we don't cover the content filter in detail because this is all changing really quickly.
Yep.
I'm wondering if we maybe just say, look, you can create your own customized content filters. This is in preview. There is a lot of changes happening in this area, but it allows us to configure the customize the harms that we are blocking against. We can configure additional jailbreak and prompt shield protections to ensure our application people are not misusing our solution, and we can use that again with any of the models, any of the text any of the text large language models from OpenAI.
Yep.
So that is the Azure OpenAI service in a nutshell. I should actually one other thing. We won't cover assistance because assistance is a little bit more. There's a lot more to assistance. But finally, let's do one last thing. We talked about so far we've demonstrated text in / text out models. So models where you take a text in and you generate text from the model. We also mentioned there's text in to image out models. An example is DALL-E. So if we wanted to use the DALL-E model, all we need to do is go to models, select the DALL-E model, click deploy, give it a name, we'll call it DALL-E 3. We call it whatever we like. Standard capacity is slightly different here, but we can essentially get up to 6 requests per minute. We're going to leave our default content filters. We will create that and it'll take a couple of seconds. We can then select the DALL-E playground, and we can now say select our deployment, which is, I called it DALL-E 3. I'm going to say a cat riding a bicycle while reading a book. And also this is actually a photograph of a cat riding a bicycle reading a book. Don't ride a bicycle while reading a book, but this cat is hopefully this cat is going to do it safely. I should have said the cat is wearing a helmet, which may be a little bit of extra safety. So it's actually going to generate that image, and there's our cat reading a book whilst riding a bicycle. We get to configure a few other things. For example, the size of the size of the image, how vivid, the certain properties of the image, how high quality we want, and whether we're going to output multiple images at once. But we could go, let's generate another copy of that, but this time a high quality one. And again, whilst it's generating, we have the same thing. We can just click the view code button. Here's the code that we would write to add this to our application. So we specify the Azure OpenAI SDK, the endpoint. We give it the key that we can get from our Azure OpenAI service. We can get it there, and we specify the client.images.generate, the model, and the prompt, and that's it. It's that simple. So now here's another cat riding the bicycle, reading a book, and wearing a helmet, just to ensure that our cat is being safe. So that's very fast run through of Azure OpenAI Studio. What we next need to do is go down into a little bit more detail around the retrieval augmented generation process. Now, that was what we were showing when we looked at the Chatto adding data source to our chat solution. We need to look at retrieval augmented generation, embeddings, and vectors, which are all key patterns and concepts we need to understand as we move towards this bring your own data to the model to reduce hallucinations, to ensure it's got access to your private data or data that's relevant to answering the questions that you need it to, rather than relying only on what the model was trained on. So we'll go on to that in the next session, and then we will talk about in future, how do we put all this together and do it at scale? How do we evaluate systems of large language models with multiple different models and technologies at play, and evaluate them at scale when we have 1,000 users all asking different things? How do we do that safely?
Uh, that's where we will touch on the Azure AI Studio, right?
Yes, that's
Yeah.
indeed correct. So
Okay.
Azure AI Studio brings all of this together along with a whole lot of other stuff into one interface, and makes that available along with a number of other core technologies like prompt flow, um, and models as a service, and not just the OpenAI models, but other models like Phi 3 and Mistral and many different other language models or frontier models are available in that system.